Hello students, this is the second part of periodic functions concept. Today in this part I will complete the total concept. So now I want to explain one important function called fractional part function. So this is important in periodic functions. First of all I want to define this. Before that we know that every real number x can be written as a integral part plus a decimal part. First of all I want to define a fractional part of a real number. Fractional part of a real number. Students, fractional part of a real number defined as positive decimal part of a real number. I will write that one only. The positive decimal part of a real number x is called its fractional part. Okay, and important, and it is denoted by this symbol, floor brackets x. Through example I will explain this. So example, okay, one more thing I wanted before that example, students listen. Yeah, note the remaining integral part is denoted by this symbol, that is called step function, step x, or greatest integer function. Okay, that's why any real number x can be written as step function plus fractional part function. So this is important. Okay, through example I can write an example 1. If x equal to 2.71, then first of all you want to write fractional part, then you need to write integral part. Fractional part is 0.71, which is less than 0 and positive. Okay, next thing is decimal integral part, that is equal to 2. Okay, now another example 2. So x is equal to 7 given. What is the decimal part? I can say 0 is the decimal part, 7.00 you can write. So what is the integral part? I can write 7. So example 3 is important, Nana. Example 3 is very important. I can keep star marks for that. If x is equal to minus 2.82, then find fractional part of x and integral part of x. Okay, should observe all of you, x is equal to actually minus 2 plus minus 0.8, that one 82. But here I can't say that a fractional part of x has a minus 0.82. By the definition it should be positive. It is not positive, no, here it is negative. That's why 0.82 is not treated as a fractional part of that real number. Okay, what you want to do now here? So you want to make a decimal part as positive. That's why you need to do one thing. Just we need to add 1 and subtract 1. Add 1 and subtracted 1. 1 is added, 1 is subtracted. Minus 2 with minus 1, minus 3. Plus here what happened? 1 minus 0.82. 82 here 9 1 0.8 0.18. Understood? So general notation, instead of actually what is the meaning of this? This negative symbol is only for 3, not for 0.8. 0.18, sorry, 0.18. So I will write clearly 0.18. So important thing is this minus is only for 3, for not total. So if you write minus 3.18, this becomes wrong again. Actually what is this one? Actually minus 3 plus minus 0.8. Now here plus is there. That's why in this way you can't write. How to write means you should write the minus on the top of the 3. So you can read as 3 bar 0.18. We can read as. Now actual x is 3 bar 0.18. So now you want to write what is the fractional part of x and what is the integral part of x. So fractional part of x is 0.18 and integral part of x equal to minus 3. Very important example. Very important example. Okay, in this way you can define fractional part and integral part. Okay, I don't want to define integral part and its behavior and its properties. I don't want its graph also. Just I want only fractional part function. What is its graph and what is its period. Okay, I don't want integral part nana. So we learn the integral part functions and number theory later. Okay. Yeah, important note. Yeah. Somebody are asking if only 5 stars or not 2, 3 stars. Okay. 5 star note. What is the 5 star note? Fractional part of x belongs to closed 0 to 1. The fractional part value may be 0 and the value should be less than 1, between 0 to 1 only. This is important. Another words I can say that, for example, f of x is given as fractional part of x. What is x? What is fractional part of x? X is called domain, fractional part of x is called range. Domain, instead of x anything you can write. For example, somebody will ask what is the fractional part of 2.73. What is your answer, Nanas? 0.73 only. Somebody will ask what is the 0.17. So what is the answer, Nana? 0.17 only. Somebody will ask minus 2.82. Just now I explained, no? So what should write, Nana? 0.18 should write. Okay. Understood? So what you are getting outputs? You are getting outputs from closer 0 to 1 only. That's why range is closer 0 to 1. So what is input? Anything you can write input. No, input is any real number. That's why I want to write. For fractional part function, what is the domain? Nana? Domain is all real numbers. But range close 0 to open 1, infinitely real numbers. So now we want to draw its graph. So that is interesting. Here only I want complete. This is x axis, this is y axis. Observe all of you. I want to draw one more line. This is actually not important. Just actually that with dotted I want. Okay. Some big marker. We can make into some dots. Okay. Dotted line that actually. Okay. Observe all of you. Now I want to draw the graph of this function. What is the function? F of x equal to fractional part of x function I want to. So I can take x is any real number, no? Here 1, here 2, here 3, here 4, here minus 1, here minus 2, here minus 3, 0 here. Observe all. So now I want to draw the graph of y is equal to fractional part of x. We need to prepare ordered pair. X is 0, y also 0, here only. Okay, x is 0.1. What is y nana? 0.1, again 0.1 only, no? Fractional part of 0.1 only. X 0.1, y 0.1 here. 0.2, 0.3, 0.4, 0.5, 0. You get a line segment like this. Okay, if x is 1, if you take a fractional part of 1, what is the value of fractional part of 1 nana? 1, I can say 0, because fractional part of 1, how can you write 1.0 you can write, no? 0 only. That's why if x is 1, so the fractional part of 1 is not 1, no, 0. That's why the value is here. But 0.99999, but the value of 0.999, so output also 0.99 only. That's why here we get open circle, here thick circle. So 1 means 0, 1.1 means, what is the fractional part of 1.1 nana? 1.1 means 0.1 here, 1.2, 0.2, x is 1.2, y is 0.2, 1.3, 0.3, like that. You want to take all the values. So you get a line segment. You want to get a 2 means 0, again 0. So here open circle. Why I am writing open circle? For fractional part of 2 is equal to 0 only. No, here only the point. 1.9999999999 means is nearer to 9999. That's why this is the graph. Similarly, you get another line segment. Similarly, here another line segment. So here another line segment. Okay. So this is the graph of fractional part function. This is the graph. Okay, important observation, students, listen here, important observation. So I don't want to disturb this graph, later I will clear it. So here for these x values, so I want to use another color. For these x values, your y's are this. For these x values, again same y's. For these x values, same y's. Means what happened? Your y values are coming periodically. With what is the period? What is the length? This length 1 unit. 1 unit. That's why function period is 1 unit. Observe, x is taken from 0 to 1, your y values are this. X is taken from 1 to 2, your y values are this. X is taken from 2 to 3, your y values are this. Means x interval is with the length 1, so y values are repeatedly occurring. Okay, periodically occurring. That's why a fractional part of x is a periodic function with the period 1. Means how can you say period 1? This length, this length, 0 to 1 length. So for 0 to length, what we are getting y values? For 1 to 2 also those y values only. For 2 to 3 also those y values only. For minus 1 to 0 also those y values only. Minus 2 to minus 1 those y values only. That's why fractional part of function is said to be a periodic function. Actually this is algebraic function. It is a periodic function. So what is period means? This length is period. That is 1 unit is the period of the function. Okay, students. So this is the fractional part of function and its period. Clearly I explained. Important, this length is period. Okay, so note, somebody will ask, period of fractional part of 2x what? What is the fundamental period of fractional part x? 1 by 2, same procedure is 1 by mod 2, same procedure, that is equal to 1 by 2. Okay, so this is instead of note I can say example, that is better. Okay, this is example 1. Example 2, period of fractional part of x by 3 is fundamental period is 1 by coefficient of x is 1 by 3, that is equal to 3. So actually you want to draw the graph of fraction part of 2x also. Actually what happened I will show here actually. So these type of graphs we learn in functions. Just I want to explain only this function because this function is there for in our topic, present topic. That's why I want to explain. Actually if you want to draw the graph of fraction part of 2x, students, how we will get, I will explain here. So here you get one more line segment, here you get one more line segment. So this is the graph of fraction part of 2x, not x. So here what I have length, this length is what? Total length 1, half repeating. So half only the period of the fraction part of function, that is fraction part of 2x. Okay, so that only you got the answer also. I don't want to disturb this graph. Okay, observe, what you got? Same half only you got algebraically. That graphical explanation, this is algebraical result. So in this way also we will get the period of fraction part of x by 3. Okay. Books, how they will ask in exam, how they will ask, find the period of x minus step x. Don't confuse, x minus step x means fractional part of x only. Okay, don't confuse. I will show you. Wait, is 1 only, because what is the definition of fractional part of x equal to any real number can be written as integral part plus decimal part, positive decimal part. Let's make this a subject. What happened? Equal to x minus step x only. Don't confuse. X minus step x means that is nothing but fractional part of x. Students, IMP note. Fractional part of some k plus x equal to fractional part of x if k is an integer. Yeah, this is also important, and while solving problem you can use this. I will show you through example. For example, fractional part of 2 plus 0.2 is given. Actually, what is this, Nana? Fractional part of 2.2 only, that is another 0.2 only. Directly I can say that fractional part of 2 plus 0.2 means fractional part of 0.2, that is 0.2 only. So one more example I will write here. Fractional part 2 plus 3.7 is given, for example. So x is acting just like 2.7, k is acting just like 2. Directly I can say that this is fractional part of 3.7. So what is fractional part of 3.7? 0.7 only. Or you add them, these two, add them. What happened? 5.7. What is fractional part of 5.7? 0.7 only. Always you are getting same, no? That's why k plus x, where is k is an integer which is same as fractional part of x. Fractional part of x is given. But the definition of fractional part of t plus x should be equal to fractional part of x. What is the least t? Positive t, that is taken as period. So instead of t you write for example 1 plus x, fractional part of 1 plus x, according to just now I explained, no, that is fractional part of x only. Fractional part of 2 plus x, that is also fractional part of x only. But among 2, 3, so on, what is the least one? 1. That is why 1 is taken as the period of fractional part. Find the period of e power, just I will write answer, just what is e power, I will write definition, I will write first of all. T plus x should be e power step x. What happened? You don't, what is the use of e, no, here? No, just this should be equal to this. What values of t happened? 1 only. That's why period of e power fractional part of x also 1 only. So period is student, another example, e power cos of logarithm of, just they will confuse you. Simple problem actually this one. So find its period. Do one thing, e power cos of log of, actually that is fractional part of x, should be, this is given problem actually. Now by using definition I want to find, actually 1 only, for this also 1 only. I will show you how 1 e power cos of log of t plus x should be equal to e power cos of log of fractional part of x. Observe here, these two should equal. I will change the color. These two should equal. Okay. Next what? These two should equal. Next what? These two should equal. What t? 1. Therefore period of this function also 1 only. Don't confuse. Important model. Find the period of cos x plus x minus step x. Plus is there. Okay. Solution. just you want to find period of this and you want period of this, plus is there, no plus. Into means you can't apply the same concept. LCM concept is not applicable between these two terms. Into is there means you can't use a concept of LCM, no? Plus and minus and division is there, then only you can use concept of LCM. So first of all you want to find the period of cos function after this function, after that you need to find their LCM. Okay, period of cos x is direct to 2 pi only. Period of x minus step x, that is like fractional part of x, that is 1 only. Now we want to find LCM of 2 pi and pi. LCM of 2 pi and 1 does not exist. Important student, does not exist. Why does not exist? I will explain here. So we can find the LCM of a irrational number with another irrational number. We can find LCM with a irrational number with another irrational number. We can find LCM with a rational number with another rational number. But you can't find LCM with one irrational number with another rational number. Irrational with rational, we can't find the LCM. Rational you can find LCM. Irrational you can find LCM. But you can't find LCM of irrational and rational. So what is the meaning of that? LCM of 2 pi and pi does not exist means given function is not periodic function. If period not exist means what is the meaning of that? Given function is not periodic function. I will write that. Therefore, given function is not periodic. That's why this is important model. Okay. Another important constant function. Actually, the definition of constant function will come in functions concept. Okay, just I will explain the meaning of constant function. Okay, for example, f equal to none of y is a function. So y is dependent upon x. X is varying, y will vary. Okay, okay. For example, f of x is given as x plus 1. So x is 1. I can say this is y. Y equal to x plus 1. X is 1, y is 2, x is 2, y is 3, x is 7, y is 8. Means what happens? X is changing, y also changing. If instead of y you have a constant number, for example some 3, so f of x equal to 3. What is the meaning of this? Y, whatever we x, your y is 3 1. The meaning of this is, what are you want to write ordered pair satisfied by this means I can write 1 by 3, 2 by 3, 4 by 3, 5 by 3, 7 by 3, all y components are same. So such functions are called constant functions. Such functions are called constant functions. F of x equal constant. So domain is varying, but range is singleton set. Range is only one element, that is 3. Such functions are called constant functions. I will write that. Okay. The function f of x equals some k, where k is a constant, is called constant function. STANT, constant function. Okay. Students, important. So I will explain here. F of x equal to some 3 given. It is a constant function. Example I will write. Example. F of x 3 is a constant function. Observe here. So what are the solutions of this? What are the order bits satisfy this? If x is 1, y is 3. X is 0, y is 3. X is 3, y is 3. X is root 2, y is 3. X is pi, y is 3. Always y is same. No? Okay. For example, draw its graph. What happened? Observe here. So actually this x axis, this is y axis, here 1, here 2, here 3, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. Okay, 1 means what? 3 only. 2 means 3 only. 3 means 3 only. 4 means 3 only. 5 means 3 only. 3, 3, 3, all 3's only. All dots. What will form? It will form a straight line which is parallel to the x axis and 3 units from the x axis. That's why the graph of f of x equal to 3. Another words I can say y equal to 3. The graph of y equal to 3 is a straight line parallel to x axis and 3 units from x axis. This is the graph of f of x equal to 3. So what happened? Now we want to identify what is the period. What is the period of constant function? So that is interesting thing. Okay, observe students. If x is 1, y is 3, x is 2, y is 3, x is 3, y is 3, x is 4, y is 3. Means for all x values, y is constant. So that's why this is said to be periodic function, but without any fundamental period. Understood? It is said to be periodic function, but without any fundamental period. Why they are saying with any fundamental period? For example, for this example, yeah, actually, f of x is given as 3. Means what the definition? F of t plus x should be equal to f of x. F of t plus x should be equal to f of x. F of x means what? 3 only. F of t plus x should be 3. What is the value of t here? Any t it happens, any t it happens. For example, t is taken as 0.3. Already x is something 4. 0.3 plus 4, 4.3. F of 4.3 is 3 only. Instead of t, you can take 7. Already this is 4.3. 7 plus 4.3, 11.3. F of 11.3 also 1 only. That means what happened here? For t, for anything you can take, any positive real number you can take. It's satisfying. The definition of periodic function is satisfying, but you are not unable to find a unique t. That's why constant function is said to be a periodic function only without any fundamental period. That one I want to write. So I want to erase this example. The graph of f of x equal to k. If k is positive, above the x axis. K is negative, below the x. That is not a big problem. This is sorry. Yeah, this is y axis, this x axis. I will mention. This is x axis, this is y axis. No, this is the straight. Oh no. Yeah, this is a straight line. So I can name it is y equal to k. Okay, any x, y is k only. Any x, y is equal to k only. Just now explain, no explanation. Okay. F of t plus x should be equal to f of x. In this problem, f of t plus x equal to f of k only in this problem. What t this happens means there exists infinite many positive t's. Okay. Just now explain, no. F of x, sorry, f of t plus x equal to k. Okay, any t, for example, x is equal to 7, fix. So t is taken as 0.3, for example, 0.3 plus 7. What is that? F of 7.3. Any x it is paired with k only, no? This is also k only. What happened? Anything you can take instead of this, anything you can take of this, anything instead of x also. So t is infinitely many positive real numbers are existing. That's why there is no unique positive real number. That's why you can say that. So why I am saying that? Somebody saying that I want to take positive number as 0.1. Another one saying that I want to take 0.00001. Another one saying that I want to take 0.00001. All are satisfying. But you can't find such unique t, no. That's why it is a periodic function only, but without any fundamental period. Okay. Here there exist infinitely many real t's. So constant function is periodic function. With constant function, periodic function without any fundamental period. Student, very important, Nana, this one. This is very important. I think explanation, from this explanation you people understood. So constant function is a periodic function without any fundamental period.